In this video, I want to take a look at type 1 and type 2 errors. Now, in your time studying A-Level Maths and A-Level Further Maths, you'll have completed many questions based around hypothesis tests, and the pattern will be very familiar. We start by defining our hypotheses, then we perform our hypothesis test by finding our test statistic, and we compare this to a significance level. And from here, we reach a conclusion. We will either accept H0 or we will reject H0. However, there is an important point here to consider, and that is the possibility of an incorrect conclusion. And this is what we call type 1 and type 2 errors. Okay, so let's just start here then with the definition of a type 1 and a type 2 error. So a type 1 error is when we reject H0 when we should have accepted. You might sometimes see this called a false positive. So a false positive here just means the same thing as a type 1 error. Okay. Now you also need to be aware about how we calculate the probability of a type 1 and a type 2 error. So for the probability of a type 1 error here, that is equal to the probability of rejecting H0 when H0 is true. And I do hope that makes sense based on our definition here of a type 1 error. Okay, so that's everything then for a type 1 error. What about now type 2 errors? Well, a type 2 error is when we accept H0 when we should have rejected. Again, you might sometimes see this called a false negative. It just means the same thing as a type 2 error. Okay, and again, you also need to be aware about how we find or calculate the probability of a type 2 error. So for the probability of a type 2 error, this is equal to the probability of accepting H0 when H0 is false. Now, don't worry too much about actually finding these probabilities just yet. We're going to demonstrate that in a little bit more detail as we work through the practice questions later on in this video. Okay, so that's everything that we need then for type 1 and type 2 errors. Let's just quickly summarize then. I think the best way to show this is in the form of this table here. So for example, if we accept H0 and H0 is true, that's perfect, right? That's true. That's what we want. However, if we accept H0 and it turns out that H0 is false, this is bad, right? We have a type 2 error. Okay. Moving on then, if we reject H0 and it turns out that H0 is true, again, this is bad. This leads us to a type 1 error. Okay, so not good. However, if we reject H0 and it turns out that H0 is false, perfect. Again, this is true and this is what we want. Okay, so that summarizes everything very nicely there for type 1 and type 2 errors. Let's take a look now at two practice questions for type 1 and type 2 errors. So let's start off here then with question 1. So for question 1, we have the random variable x, which is binomially distributed. We have a sample of 15 that's taken, and it is desired to test p equals 0.4 against p being strictly greater than 0.4 using a 5% level of significance. So for the first part of this question, part A, all I want to do here is find the critical region for this test. So for part A then, finding the critical region, this should hopefully be nice and straightforward, or the first part anyway, because this is just a basic A-Level Maths stats question. Okay, so the first thing that we need then is our distribution here for our random variable x. So x is binomially distributed. So x is binomially distributed, and what I'm going to do here is assume that H0 is true. Okay, so if H0 is true, we have our two parameters here. We've got n and p. So n, that's our sample size, which is 15 in this question here. So n equals 15, and then p, our probability here, well, if we assume that H0 is true, p equals 0.4. Okay, so I put 0.4 here, and that gives us our distribution for this question. Now, what we require here is a value c, such that the probability then, so the probability here of our random variable x, is greater than or equal to some value c being less than 0.05 here. Okay, because we have a 5% level of significance. So it's up to you how you do this, whether you use the tables in the back of your formula book or whether you just use your calculator. I'm just going to use my calculator here. So what I'd get here then is the probability that x is greater than or equal to 9. Now that would be equal then to 1 minus. So 1 minus the probability that x is less than or equal to 8. Like so. Put this into your calculator then. So what I get here is 1 minus 0.905. So that is equal then to 0.095. So 0.095. And notice here this is greater than 0.05. Okay, so that's greater than 0.05. So we need to keep going here because we haven't satisfied this condition then. So in that case then, let's keep going. So we'd go larger here for these values. So I'd have the probability that x is now greater than or equal to 10. Like so. Well, that would be equal then to 1 minus the probability that x is less than or equal to 9. Less than or equal to 9. Again, just put this into your calculator here. So what I get then is 1 minus, so 1 minus 0.966, like so. And this gives me 0.034. Okay. And in this case then, this is less than 0.05. So that's less than 0.05, and therefore we've satisfied this condition here. Okay, so what that gives us then is the critical region. So therefore the critical region here, part A, so the critical region would be x being strictly greater, sorry, not strictly greater, x is greater than or equal, there we go, to 10. Okay, that's this value here. Okay. So there we have it, so that is the critical region, giving us a solution to part A. So let's just quickly box this off then, just so we can answer part B. We'll box it off here then. So that's part A done. What about part B then? So for part B, it says state the probability of a type 1 error for this test, and given that the true value of P was later found to be P equals 0.45, find the probability of a type 2 error. Well, for the probability of a type 1 error, you might not be aware, but we have already found that. So for the probability of a type 1 error, let me just write this down here. So for a type 1 error here, well, this is equal then to the probability that x is greater than or equal to 10. In other words, we are within the critical region here, given that P is equal to 0.4. Okay. And as I mentioned, we have already found this. We did this for this part here. Okay. So the probability that x is greater than or equal to 10, given that P equals 0.4, because we assumed that H0 was true. So P is equal to 0.4 here. So we've already found the probability of a type 1 error. And in that case, then that is simply this value here of 0.034. So 0.034. So that's the first part there. That's the type 1 error. We now also need the probability of a type 2 error. So for the probability of a type 2 error, let's just write this down here. So for the probability of a type 2 error, this is equal then to the probability that x is less or equal to 9. In other words, we are not within the critical region here. So x is less than or equal to 9, given that P equals 0.45. Okay, because that's what P is later found to be. So P equals 0.45 there, like so. And again, just use your calculator here to find this probability. Nice and straightforward. Then if you do this correctly, what you should get then is 0.923 there. Okay, and there we have it. So that gives us the solution there to question 1. And if we just take a look then at one more question here, we have question 2, where this time now we are looking at a Poisson distribution. So the random variable x has a Poisson distribution. A sample is taken and it is desired to test lambda equals 5 against lambda being strictly less than 5, using a 5% level of significance. And as you can see for this question here, the layout and structure is very, very similar to the previous question. So again, we're just going to start by finding the critical region for this test. So for part A then, just finding the critical region. Well, we need our distribution here. So x has a Poisson distribution. So x follows a Poisson distribution here. But what we need here is the parameter lambda. Well, it's desired to test lambda equals 5 against lambda being strictly less than 5. So if I assume that H0 is true, then lambda equals 5. So our parameter here is 5, like so. So that gives us the distribution. What we now require is a value c, such that the probability, so the probability of our random variable x here, being less than or equal to some value c, is less than our significance level here of 5%. So that would be less than 0.05. Okay. So what I'm going to do here is just find this probability then. Well, I'd have the probability that x is less than or equal to 2. So the probability that x is less than or equal to 2. What would that give us? I'm going to get 0.125 here, like so. And this doesn't satisfy this condition then. So this is greater than 0.05. So it's greater than 0.05. So we keep going here. In this case, this would get smaller. So the probability that x is now less than or equal to 1. So less than or equal to 1. Again, just use your calculator here to find this probability. And if you do this correctly, what you should get then is 0.0404. Okay. And notice here, this is less than 0.05. Okay. So therefore, we have satisfied this condition here. So we have now found the critical region. So therefore, the critical region here. So the critical region is x is less than or equal to 1. Okay. And there we have it. So that is the solution to the first part of this question, part A. Again, let's just box this off so we can answer part B. So for part B then, it says calculate the probability of a type 1 error, and given that the true value of lambda was found to be 3, calculate the probability of a type 2 error. So again, this should probably say state the probability of a type 1 error because, if I change that to state, we have already found the probability of a type 1 error. So the probability of a type 1 error, let me just write this down again. So the probability of a type 1 error this is equal then to the probability that x is less than or equal to 1. In other words, we are within the critical region here. So x is less than or equal to 1. In other words, like I said, we're in the critical region, given that lambda is equal to 5. Okay. Given that lambda equals 5. And as I mentioned, we already found this probability here. This was this value. So 0.0404 there. Okay. So that's the probability of a type 1 error. What about then the probability of a type 2 error? So the probability here of a type 2 error like so. Well, this is now going to be the probability that x is greater than or equal to 2. Okay, so in other words, we are not within the critical region now. Given that lambda, well, what was lambda later found to be? Well, that was 3, right? So given that lambda equals 3. Okay. So what you need to do here now is calculate this probability. So what you should get then is 1 minus, we get 1 minus 0.199 here, which if we evaluate, gives us 0.801. So we get 0.801 there. And there we have it. So that gives us the solution there to the very last question, question 2. And that actually brings us to the end of this video on type 1 and type 2 errors.